Hello everyone, my name is Minghan Zhu. In this video, I will present our work from Qualcomm and University of Michigan for the panoptic segmentation as invariant and equivariant field prediction. The task for the panoptic segmentation is a combination of semantic segmentation, instance segmentation, and object tracking. Given sequential point cloud input, the expected output is per point semantic class and temporally consistent per point instance ID. Since the scene layout and object movements are all approximately on the ground plane, we leverage SE2 equivariance in this task, which is to enable generalization to planar rotations and translations by construction. There's a gap of incorporating equivariance in practical large-scale perception problems, such as point cloud segmentation, partly due to the efficiency limitation. Nevertheless, our equivariant model brings improvements in both performance and efficiency to this task and achieved #1 in Semantic Kitty leaderboard. This is an overview of our network. Without going into the details, we can abstract it into this diagram. We first aggregate the sequential scans together and use an equivariant encoder, which is E2PN here, to extract the features. The features are processed through two modules called invariant field prediction and equivariant field prediction, and then fed into the semantic and instance segmentation heads. We will focus on the invariant and equivariant field prediction in this presentation. In our context, a field is a mapping from R3 to some vector space V. Following this definition, any dense predictions assign some property to every point in the space. Thus, is field prediction. For some fields, the vector space V is a scalars R1. For example, semantic class and occupancy value. They do not change when the field transforms, so we call them invariant fields. For some other fields, the values in V are vectors. Some examples are the velocity vectors and surface normal. They will rotate along with the field when the transformation is applied. Thus, we call them equivariant vector fields. We will now use this perspective to discuss the instance segmentation approaches. Instance segmentation identifies individual objects in a point cloud, which is an important subtask in our problem. In literature, there are two strategies to estimate object center. The first is called centerness prediction. For each point, the ground truth centerness value is large when it is close to the center of an object, otherwise small. We can see that the centerness heat map is an invariant scalar field. The second strategy is called offset prediction. For each point, the vector from that point to the object center is regressed. The ground truth offset map is an equivariant vector field. An equivariant network can be used to predict invariance and equivariant targets. So we ask, in the context of equivariant learning, is one strategy better than the other? We answer this question through experiments on the Semantic Kitty dataset, which contains over 40,000 LiDAR scans. We look at the object segmentation metric, IOU, of things, and we have 3 findings from the table. First, when we are not using the equivariant model, both centerness and offset prediction yield similar accuracy. Second, the introduction of equivariant learning boosts the performance of both methods. Third, the improvement brought by the equivariant model is much larger when we use the offset prediction method, where the target is formulated as equivariant vector fields. Here is a figure of the overall performance and efficiency. The first column is the non-equivariant baseline, and our models are on the right, with different rotation discretizations. Our equivariant model achieved higher accuracy with lower memory consumption and faster running speed. Furthermore, our model ranked #1 on the Semantic Kitty public leaderboard. In conclusion, we developed the first rotation equivariant LiDAR panoptic segmentation model, which achieved better performance and lower computational costs at the same time. Furthermore, we found that it brings more benefit to design the targets as equivariant vector fields for equivariant models. Check out our project page at the link below for open source code and more information. Thank you.